Question 3d. Use mathematical induction to prove that 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus plus 1 over 2n minus 1 times 2n plus 1 equals n over 2n plus 1 for all positive integers n. The first step is to show the statement is true for some value of n, and in this case the smallest value of n that we can test is n equals 1. From the left hand side of the statement we have 1 over 1 times 3, which is equal to 1 over 3, and the right hand side of the statement is equal to 1 over 2 times 1 plus 1, which also equals 1 over 3. The left hand side equals the right hand side, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k for integer values of k greater than or equal to 2. That is 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus plus 1 over 2k minus 1 times 2k plus 1 is equal to k over 2k plus 1. Next, we show the statement is true for n equals k plus 1. So from the left-hand side of the assumption, we have 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus plus 1 over 2k minus 1 times 2k plus 1 plus the next term along, which is 1 over 2k plus 1 times 2k plus 3. Now we can replace these terms with the right-hand side of the assumption. So we have k over 2k plus 1 plus 1 over 2k plus 1 times 2k plus 3, and I've just made the note here that it's from the assumption. And that equals k times 2k plus 3 over 2k plus 1 times 2k plus 3 plus 1 over 2k plus 1 times 2k plus 3, and that's by finding a common denominator. Now that we have a common denominator with both fractions, we can add the numerators together. So expanding the brackets here and adding both numerators together, we get 2k squared plus 3k plus 1 over 2k plus 1 times 2k plus 3. And factorizing the numerator, we have 2k plus 1 times k plus 1 over 2k plus 1 times 2k plus 3. And the 2k plus 1 in the numerator cancels with the 2k plus 1 in the denominator. And so we're left with k plus 1 over 2k plus 3, but n equals k plus 1. So rewriting this expression in terms of n, that equals n over 2n plus 1, which equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all positive integers n.